Uh, Assalamu alaikum. Good noon from Pakistan and good morning from this African country. So I think I am audible to all of you. If you can hear me or you can see the screen, just write in the text so that I will continue.
Yes.
Okay, so I'm audible to all of you. Okay, so today we will talk about. So I'm again Dr. Samiullah, Assistant Professor, Shahid Benazir Bhatti University, Shingal Dirapar. So today we will cover the following topics. For example, we will know about that what is actually land use, land cover, and its planning using GIS and remote sensing. We will repeat the exercise of unsupervised classifications, as well as we will also repeat the exercise of the supervised classification. But today I add one more practical exercise, and that's actually the using the open or statistical software for image classification. So actually, this is very good. Our statistics software is very good. So this software can be used for a variety of applications. You can do difference of statistical and there are thousands of packages available of the R statistic. So we will using some package to utilize the R open source software specifically for the image classification. So this will also be our today topic, or it will also be a part of our practical session. And the most important thing that this is open source software, so you don't need to buy it from anywhere. You just have to download, and then accordingly you have to use for different application, for a variety of application. And one of the best application is that image classification or image analysis with the R statistics software. And the most important thing that you have here in dependency, you can change the model, you can tune the model, and you can use different kind of classification, non-parametric classification algorithm. You can do some regression with it and some classification. So this will also be a part of our practical session today. Okay, so let's move to our small introduction of land use, land cover. So if you think that land use and land cover is actually composed of two words. The first is, for example, land use, and the second is, for example, land cover. So in simple, land cover means that how much of a region is covered by a forest, wetland, impervious surfaces, agriculture, and other land and water types. So this simply tell you that how much region is covered by one land cover types. For example, how much percentage of area of forest is there, how much percentage of area is agriculture there, and how much percentage of area in the form of wetland, or maybe some habitation building, or maybe water bodies. So this only documents the how much area is covered by a specific land cover types. But also we have land use. This is another word, land cover and land use. So in simple, land use tell you that how people use the landscape, because forest can be used by somebody, and agriculture can be used by someone. Water can also be used by somebody, and buildings or habitation can also be used by somebody. So land use show how people use the landscape, whether for development or conservation or mixed uses. So it's related to the uses of the landscape. So that's why we are always combining these two words: land use, land cover, land use, land cover, because land use apply that how the land can be used. But as far as land cover, just document how much area is covered by specific land cover type. So these two are very important, and they cannot be inseparable. That can all you can always have to use these two words together: land use, land cover. So in a more detail, for example, land use are defined by economic terms. So because when you are using land, so you are getting something from a land cover. So that's why it can be defined by economic term. But land cover is something like a visible feature that you can see on the surface of earth. For example, if it's a barren land or agriculture land or forest or something like that. So both of these words are very important and are really inseparable. So that's a short description. As far as the importance of a land use, land cover is concerned, so as you know that anthropogenic activities are continuously altering the natural rate of exchange of carbon between the atmosphere and the terrestrial biosphere reserve through land cover changes. For example, the human activities are continuously involved in converting the natural land cover classes. For instance, one of the most prominent example is forest. So people are cutting forest for agriculture land. People are using forest land for building, for agriculture, for other activities. So when you cut the forest, the stored carbon which is present in the trees can be released into the atmosphere. So if it's released in the atmosphere, if the concentration of carbon dioxide is increasing, as a result, it will trap more infrared radiation from the backscattering of the earth surface, earth surfaces. So the more carbon dioxide concentration in the atmosphere, the more will be the portion of the high will be the temperature. So as a result, you will know that global warming kind of calamities will happen, and the earth surface is warming day by day. Second, for example, land use, land cover has a direct impact on water, atmosphere, and soil erosion, and is thus directly or indirectly related to many issues of global importance. If you go back, for example, I didn't give citation to that line, but if you go back up to 8,000 years ago, for example, 50% of the earth surface was covered by the forest. And nowadays we have only 30% forest left in the earth surface. And also, you know, this 30% forest is under a tremendous pressure due to the ever increasing human population day by day. And also, you know, nowadays the forest fire is also one of the main factor. Specifically here in Pakistan, we have observed in last month many forest types, many forest fire that happen in different forest types of Pakistan. So that's also one of the issues. So forest area is decreasing day by day, mainly due to agriculture, due to building construction, due to road, or due to other infrastructure activities. So if you take example, for example, agriculture land has replaced the forest, savanna, and steppe in many parts of the world to meet the food demand of the growing human population. So land use, land cover assessment is an important component in the planning, monitoring, and sustainable utilization of natural resources. For example, when we assess land use, land cover, then at least we will know that what is going on actually on the ground, how much area of a forest is left, and how much area has been converted from forest to other land use, land cover. Then we can even plan for it, or we can even monitor it, or so to ensure the sustainable utilization of natural resources. we need to have a very accurate information about land use land cover classes. So finally, for example, it's crucial to understand, evaluate, and monitor the land cover resulting from the anthropogenic activities for better planning and management. So that was the small importance of land cover, land use land cover types. The next is our land use classification system. For example, what is this? Which kind of system we are applying for land use classification system? So in a very simple, that a land use classification is a classification providing information on a land cover and the types of human activity involved in land use. For example, it gives you information about that which kind of land cover. Okay. Yes, Zahid, you're right. Yeah, Zahid wrote in the text that world has 422 trees per person, while Pakistan only 5 trees per person. Yeah, that might be right, but yeah, this number of trees, the counting of number of trees is also a big concern. Okay, so maybe it's okay for a general assumption, but practically maybe we have to count the number of trees as compared over the population. But this is really a sense if you just divide the percentage of forest cover as compared to the population of Pakistan. We have only 4 to 5% forest, and we have some 2,200 million population. So it really makes sense. Yeah, right. So land use classification is a classification providing information on land cover and the type of human activity involved and land use. So for example, it's actually we classify the land use or land cover, and we also know that which kind of human activity is associated with that land use. So it's actually classification of the land use land cover and the type of human activity involved in land use. For example, when you classify agriculture land, so it's simply that the humans are getting agriculture crops from it. When you classify a forest land, it means that the humans are using the forest resources. So that's a kind of definition. So it may also facilitate the assessment of environment impact and potential alternative uses of land. So for classification, land use land cover classification, we have different kind of data sets. We have, for example, level 1 products, level 2 products, level 3 products, and even level 4 products. For example, when you are doing a classification, you can be asked that, okay, what level of a products land use land cover classification you are giving to us. So whether it will be a level 1 products or whether it will be a level 2 products or level 3. So the more the products, for example, level 1 is a little not that much in detail, but level 2 is much detail, level 3 is much more detailed. So as you go, so sometime we are going up to level 4 products. So for example, the agriculture land, this is a kind of level 1 product. We are classifying the satellite data into agriculture land or forest land, built up land, scattered farm building, wet open land, dry open land with special vegetation, open land or with insignificant vegetation cover and water. So if you can have a look here, for example, you can see we have different level of a classification system. For instance, here we have level 1. In level 1, we classify the lands satellites data into urban or built up, and then in a second into agriculture, then rangeland, forest land, water body, wetland, barren land, tundra, and perennial snow. So what we will do in our practical session, this will also be a kind of level 1 product. But if you want to go into much more detail of the classification system, for example, if you want to classify level 1 products, into more detail. For example, the urban or built-up area can further be classified into residential, commercial and services, industrial, transportation, communities and utilities, and industrial commercial mix, or urban built-up land, other urban or built-up area. But if you go much more detail, for example, with the urban or built-up land, you have to classify them into single family units, multiple family units, group quarters, residential hotel, mobile homes, transportation, lodging, and other. So you have to use, for example, for urban or built-up, you have to use, for example, one. And then if you want to classify residential, for example, which is a kind of level 2 classification, but it's on the top, so you have to give a name 1-1, or you have to label as a 1-1. So then the expert know that it's an urban area, but that's actually residential area. If you give a name 1-2, then the expert will identify that, yeah, it's urban area, but it's commercial and services. The third, if you go with the level 3 products, you have to give, for example, 3 digits labeling. For example, 1-1-1. So one mean urban or built up. The second one mean it's a residential. The third one mean is a single family unit. So you accordingly you have to classify. If you come to forest, for example, if you just classify the satellites data into forest, it will be level 1 product. But if you go into much more detail of the forest classification, like for example, if you further classify deciduous forest land, evergreen forest, mixed forest, then it can be a level 2 product. But if you want to go much more detail, maybe into compartments or maybe copes or some other detailed classification of the forest land, maybe a tree species mapping, then it will be a kind of level 3 products. Okay. So there is multiple level of land use classification systems. So for example, level 1 and level 2 and level 3, but sometimes you go with much more detail of level 4. Okay, so what actually we are using when we are classifying the land use, land cover classes, the color which we are using, which internationally acceptable. So I took this color from the US GS web, US United States Geological Survey for the level 1 land use, land cover. So when you want to give different color, for example, urban or built up land, normally we are giving red color. So for agriculture land, we are giving a kind of light brown color. For rain land, we give light orange color. Forest land, we usually give green. Water, dark blue. Wetland, light blue. Barren land, gray. Tundra or forest, for example, green gray. Perennial snow or ice, we keep it white. So actually, if you create a map for the people with which easily understand, you have to follow the following color. Like for example, for urban or built up, you have to give red lights, red land, red color, and for agriculture land, you have to give a light brown. But if you give, for example, light brown color to red, then the people will be confused that it's agriculture or urban. Although we have legends of every maps, but we have to follow the following color according to the USGS, United States Geological Survey. They are very okay. So now this is the kind of map of, for example, level 1 products and then level 2 products. But this is actually not a classified map, but this is a kind of classified map. But then this is further converted into digitized into vector data. So that's the kind of thematic map. It contains vector data. So it may be lines, points, polygon. So if you can have a look to this map, it's very simple. So for example, if you can see that it is 1 written here, here also 1, here 1. So it's clearly indicate that these are urban or built up land. But if you see where if there is some 2 written, for example, this is 2, It's a little smaller. So it's mean that here is agricultural land. If you go to 4, you will find 4 somewhere. It's mean that it is a forest land. Specifically, if you find 5, they give 5, or number 5, it's the water, and then barren land they give us 7. The same you have the level 2 products, a digitized map, a thematic map. They give, for example, 1-1. 1-1 mean that it's urban or built up land, but inside the urban or built up land, it's actually a residential area. So the second is, for example, 1-2. It's 1 means urban or built up, but 2 mean that it's commercial or and services. 1-3 mean that's also urban or built up, but it's an industrial zone, something like that. So specifically for agriculture, also there is some information for forest, for deciduous forest land, confined. So whenever you are classifying into different levels, so you have to follow the number, the digital number. For example, 1 at the level 1, and if you go with the level 2, it will be 2 digits. But if you go with the level 3, it will be composed of 3 digits. If you go with the level 4, it will be composed of 4 digits. So level 1, 1 digit, level 2, 2 digits, level 3, 3 digits, and level 4, 4 digits. So accordingly, you have to label your data sets. So this is also more one figure. For example, it's a level 2 products, and also this is a level 3 products. Yeah. So you have to follow this also. So after that, your topic is, for example, land use mapping. We already dealt this practically, I mean, in our last exercise, but also that is here. For example, land use mapping reflect the land resources and type. That is right. So if you want to map, that's also practical. You also did last time. So you have to select the images, okay, first. And what season, what dates are the most important, most significant date of what date you want to, for example, download the images, and what season of the images you want to download. The second is, for example, processing. As I told you, it's the accurate registration and atmospheric correction. Succeeding need to be done carefully. As I told you, that it need a pre-processing steps. For example, from atmospheric correction. So the first thing, selection of the images. When you download, you select the images. The second step will automatically start the pre-processing or processing step. That can be accurate registration or atmospheric correction. Or registration means like geometric correction. If there is a shift, you have to bring all the images into exactly 1 and above, and you know about the process of georeferencing, so you can do this, can also be done with the georeferencing. Atmospheric correction, there are a variety of atmospheric corrections available. Some are available in ArcMap, but many atmospheric corrections are available in the Ardas image, and you will find very good. Maybe in ENVI there are different atmospheric corrections available, but majority of the data, as I told you, that it comes in the form of level 1 products or level 2 products. So these kind of pre-processing steps were already done by the productions from where we are getting the data. The next is the, for example, classification algorithm. That's also our steps, for example. And you know, there are a variety of classifications available, as I told you, supervised classification, unsupervised classification, object-based segmentation, and non-parametric classification, which include random forest, support vector machine, neural network, deep learning. So it's up to you that which algorithm you want to choose, or what techniques you want to apply. So and the most advanced algorithm, the most accurate result will be. But even you can use sometime a combination of classification output and then merging and then finally getting a very accurate data. This is also a thing. So the final is, but we gave assignment of spectral classes to the information classes. That is what we discussed, it how to assign. For example, for forest, you have to give maybe three, and then for deciduous, you have to give, for example, 3-1 or 3-2, something like that, as we discussed before that. So the labeling, that will be the your fourth option. And finally, you have to do display and symbolization, like, which consists of color choices. As I also give a small indication that which color you want to use. For example, for forest, we are applying green. For build-up, we are applying, for example, something like red, or for water, we are going with the dark blue. But today we will do this practically. So these are actually some steps, like, for example, selection of the satellites images. This is the first, and then processing, and then classification, and then assignment of spectral classes to information. And finally, you have to go with the display and symbolization of that thing. So yeah, then you will have the final output. Sometimes we also doing with the land use change detection. So for land use change detection, you have to know that two maps, because with one map you cannot identify any change, but if you have two maps, a temporal satellites data, for example, one in 2010 and the second in 2020. So when you have two maps of the same region for different dates, then you can easily depict land use, land cover changes, then it's possible. But you have to keep in mind that you have to use the same classification system. For example, if you are applying maximum likelihood classification in 2010, and then you applied support vector machine in 2020, then your result will be not good. So whenever you are going for the land use, land cover classification, you have to use the change detection. You have to use the same classification system, the same month of the image acquisition. Because, for instance, if you take a satellite's image in 2010 in winter, and if you take the satellite's image of in 2020 in summer, and you want to know that how much forests have been reduced or increased, automatically there will be change, because the broadleaf tree has no vegetation in the autumn season. So the forest area will be less, comparatively less. So you have to select the same month, the same growing season, and the same even the pixel resolution, the resolution. So your data will be spectrally, spatially, as well as other parameters, geometrically or atmospherically, will be same for depicting land use, land cover change detection. So there are a variety of techniques. For example, we can use even image algebra, or very simple techniques. That is, for example, you can apply for a single band. If you subtract one band of 2010, for example, if you have infrared band of 2010 and you have infrared band, for example, in 2020, if you subtract one from the other, it will also give you some indication of the changes. For example, the value where there isn't many change have been taken place, the value will be in the form of 0 or very small difference. But if there is a significant change taken place, then there will be a difference between the digital number. And you can, so here must select the threshold, but you have to decide afterward what threshold can be applied for change or no change. Also, image ratio can also be applied. You can just divide one image by other, and you can calculate some change detection. This is by using the image algebra. The second is, for example, classification. For example, if you classify a satellite image in 2010 and then you classify the satellite image in 2020, and if you do comparison of these two classification, what we call it post-classification comparison, we call this post-classification comparison. So with the post-classification and comparison, You can also calculate the land cover change. For example, very simple, if you just calculate the area of a forest in 2010 and then area of forest in 2020. So if in 2010, for example, it's 20%. So in 2020, for in 2010, it's 20%, and 2020, it's 15%. Simply said that 5% forests have been cut. But there are other techniques which where the forests have been cut, the exact area and which class the forests have been converted. That we are also using. And I think in my last lecture, I will show you some of my paper where we exactly identify the area where each land cover has been converted from one land cover to another, and what is the exact location of that. But that can be also called a post classification or something like that. We also have some multi-date composite bands. If you have different band from temporal data, and just make a composite of that by using different techniques, or maybe some thing like pretty unwidely. It's a little complex, but if using these principal component analysis techniques by combining different bands of different dates, it also gives you some direction or some direction that where exactly the changes have been taken place. Or in a very simple, that is, for example, on screen digitization, if you have two screens, if you just classify your satellite data into different polygons, or different polygon of different sizes of equal length, if you just have same area on one screen and the same area another screen of a different date, you can visually see some changes. That oh, here was the forest, but here the area looks abandoned. Then you can make just a digitize or line or polygon on it, then it's also possible. With the on-screen digitization, you can do some change detection. So land use planning, why it's important, or why we are doing this, for example, why we are talking about land use planning. So land use planning, as you see, and development is simply is a process by which community leader allocate these resources and establish a policy for the use of land to facilitate the best development for the general welfare of the area resident. For example, land use planning is actually the community leader, or maybe the administrative leader. They allocate specific area that, for example, here a town will be constructed for the people. Here a school will be constructed. These area can be located for a forest, and these area can be located for a water. In the developed countries, you know, they whenever they are planning, for example, towns or cities or something like that, they have specific portion for green spaces in the form of rectangular blocks or maybe line transects, because this vegetation, green spaces, has a cooling effect, and also it cleans the environment. So that's actually what we plan. For example, whenever we are doing some planning, for example, where the industrial zone can be located, or because and how much area, how much far the industrial zone can be from the habitation, and something like that. That is actually all about the land use plan, how where the market will be exactly, so that all the people have access to the market, where the hospital will be, so that all the population or the inhabitants can have access to the schools or markets or whatever. That is actually a kind of land use planning. But you have to keep in mind two things. The first thing, while doing land use planning, you have to think about the social and environmental outcome. These two are the most important things. So you have to think about the people which are living in the area, and the second, you have to think about the environment. So in the environment, you have to think about, for example, the soil or forest or land and air, etc. These are the important things whenever you are doing a land use planning. So more specifically, the goal of modern land use planning often include environmental conservation. Environmental conservation will be on the top priority. For example, so the soil cannot be deteriorated, the water cannot be contaminated, the forest cannot be decline. This can be the environmental concern. And also, restraint of urban sprawl. The urban population is growing considerably day by day due to ever increasing human population. So that can also restrain the urban sprawl. Specifically, you have to motivate the urban to construct their buildings or cities in area where this kind of water or soil or atmosphere cannot be degraded. So minimization of transport cost is also be keep in mind while planning land use planning, because if you construct a village or city in a far flung area, you need to have a car or maybe a bus or maybe a railway or something. But that also has an impact on the environment. So you have to select an area where people have very easily access to that. The third is, for example, prevention of land use conflict. That's also a big challenge. If there are a lot of conflicts available between the humans or maybe something like that, so you have to select an area where there are conflict free, and also an area which is a reduction in exposure to pollutants, like for example, the atmospheric pollutants. So a government actually use land use planning to manage the development of land within their jurisdiction. That's right. So for example, if government have no jurisdiction, they cannot do such kind of land use planning, but although they have some rules and laws that they can go there if there is a problem of deterioration of land, of soil, water, or atmosphere, something like that. So in doing so, the government unit can plan for the need of the community while safeguarding the natural resources. So you have to be kept in mind whenever you are doing planning for land use planning, you have to keep in mind the community need. But you don't need to forget the natural resources. So the community need can be fulfilled, but not on the cost of deterioration of the natural resources. So we have to do a kind of strategy to manage the land to get maximum benefit from the land for the local inhabitant, economically, socially, environmentally, you have to keep in mind. So to this end, land use planning is the systematic assessment of land and water alternative for land use and economic and social condition in order to select and adopt the best land option. This is actually what we are doing land use planning. So a land use plan, for example, provide a vision for the future possibility of development in the neighborhood districts, cities, or any defined plan area. In United States, for example, they are using a different kind of wording, like for example, land use planning or regional planning or urban planning and urban design. These are different kind of words which are often used interchangeably and will depend on the state, country, and on project in question. So despite confusion nomenclature, the essential function of land use planning remains the same, whatever term is applied. So whatever, if somebody is using regional planning or land use planning or urban planning or whatever wording, but we have to keep in mind the essential function of the land remain the same. That is actually the social, the planning of the land resources for the social, for the economical, as well as for the environmental, for the present as well as for the future generation. This can be kept in mind. The Canadian Institute of Planners offer a definition that land use planning means the scientific, aesthetic, and orderly disposition of land, resources of facilities and services with the view to secure the physical, the physical, economical, and social efficiency, health and well-being of urban and rural communities. So as far as the Canadian Institute of Planner, they put all the objectives. Like for example, if you're doing land management, it can be scientifically good, but it can be also aesthetically looks good. An orderly disposition of land. Orderly disposition, you cannot disrupt the disposition of the land. Resources, for example, you cannot degrade the resources. When doing planning of land, you have to keep in mind that the resources cannot be degraded. Facilities and services with the view to, so you have to provide different facilities to secure in the physical, economical, and social efficiency, health and well-being of the urban and rural communities. So you have to keep all these things in mind whenever you are doing a land use planning. The American Planning Association states that the goal of land use planning is to further the welfare of the people. So whenever you're doing a land use planning, you have to keep in mind the welfare of the people and their community by creating convenient, equitable, helpful, efficient, an attractive environment for present and future generations. So the two things is important whenever you're doing a land use planning. In a conclusion, for example, you have to keep in mind the welfare of the local people or local inhabitant, as well as to safeguard the natural resources or the natural environment. You cannot go with the land use planning and the cost of deterioration of the, for example, this natural environment. So these all things can be. So importance of land use planning. If you don't have any planning for land use, what will be the problem? For example, without a proper land use plan, cities and community would be in a disarray. For example, your cities or communities can be something like in the single things. If you just have a look in Pakistan, for example, when there is town, you have all the facilities in the town. For example, you have a very good road, you have park in the town, you have school, you have college, you have university, you have hospital, everything. So because this park was designed with some specific land use planning, but if you just go into the public area when there is no planning done, there is a problem of road, there is a problem of sanitation of water, there is a problem of disorderly arrangement of the homes, and there is a lot of conflict. So that's the thing. So without a proper land use plan, cities and community would be in a distress. Transportation, as I told you, that would not be run efficiently because the road will not be in that much good, which ensure the transportation of the city. Industrial plant would pollute if you don't have any plan of a land use planning. So the industries will be just in the middle of the and the habitation. What will happen? The industrial plant will pollute the residents' waterway, because this water can go deeply into the soil in the form of infiltration, and the water table will also be affected. The air quality of the surrounding area will also be not good. So cities would be unwalkable, communities would be unsafe, economies would be stalled, the environment would be damaged, and resources wasted, which would leave the area unsuitable for the future generation. Land planning has been, if you go back, it's been around since ancient time, when people began to, for example, congregate in a larger group rather than as an individual nomad and small tribes. So when village develop into larger metropolitan, and land planning become essential to their daily life. So whenever the rural people are moving from rural area to the urban environments, so we need a land use planning. So without land use planning, we will have all these problems. problem of the roads, problem of the atmosphere, cities would be unwalkable, community would be unsafe, environment would be damaged. So there are a variety of problems related with the land use, land planning, if we cannot do a proper land use, land planning of any area. But just I always focus on the social, environmental impact. You have to keep this mind for our present as well as for the future generation. So in today, there is a growing awareness of our impact on the environment. We understand that each of our activities leave a carbon footprints. Okay, for example, whenever we are establishing a city, or we are cutting maybe so what activities we are doing in the form of a land use planning or land use land cover, so for example leaves a carbon footprint. For example, if you built a home and the cost of cutting of the forest, so you know what will be happen. This will increase. This will release the atmospheric carbon dioxide which was present in the trees. So, and then when you are doing some cooking and you are cutting the trees for heating purposes or some other thing, it will also leave a carbon footprint. If you construct a road and the cost of cutting of the forest, so this will also give a carbon footprint. So the growing conscience mean that we are paying attention to our living and working pattern, how they intersect, and how to live in a way that preserve the environment. So whenever we are doing some land use planning, we have to think about its negative impact in the form of carbon footprints. So there is a bargaining need for the walkable community, mixed-use development, and green spaces for the people to live, work, and place with a short distance to reduce commute time and encourage low-emission transportation such as walking or bike. So there is a high need for us, for the walkable community, to mix use their development and to establish a green spaces everywhere in the form of vegetation, plantation, block plantation, linear plantation. I think whenever we see a blank space in the area, we have to go for the plantation and to reduce the distances, because for distance, the one thing you have to use the vehicle, and for vehicle you have to use the natural resources. So you have to use the oil, something that can also create a problem in the atmosphere. And low emission transportation options such as walking or bike, we have to encourage walking or bike. Forest area are constantly converted into other land cover classes. It is highly important to know the dynamics of conversion of forested area into other land use land cover classes for protection and conservation purposes. Also, you know, these developed countries like US and China and India, for example, releasing a huge amount of carbon dioxide into the atmosphere, and that continuously increasing the global warming. I mean, the temperature, land surface temperature, which has a very bad impact on the polar ice or the area, the countries which are just on the sea level, and also for the biodiversity of biodiversity, local biodiversity of the tree species, that is plant and animal, something like that. So this was a little bit importance of land use planning. So finally, we have to come that what is the role of GIS in the remote sensing and land use planning. So as you know, that the development of information technology has significantly changed the approach to land use and spatial planning, and management of the natural resources. For example, you know that the information technology is increasingly growing, and that has really changed the approach of land use and spatial planning management of natural resources, because it's very difficult to go physically on the ground to calculate the area, big geographical area of any land cover type. For instance, we just take an example of a forest land which is located in the large geographical area. If you give a task to measure the forest area of a single mountain, it will take considerable time. But no, we have satellites images. In the satellites images, you can see the forest of airy area, the eye bird view. That's of the satellites images, and you can easily analyze for assessment, for planning, or monitoring, something like that. So GIS considerably simplifies territorial planning, operating, analyzing the necessary data concerning their spatial relationship that allow carrying out complex assessment of situation and create a basis for adaptation of a more exact and scientifically reasonable decision in the course of land use. Yeah. To assess, for example, the current land use situation and the possibility of modeling possible future changes associated with the complex of adopted measure, GIS allows the integration of diverse data. For example, GIS will not actually working with a single data type, but you can even do a integration of a diverse data. You can take the soil data, you can take the climate data, temperature, rainfall, humidity. You can take vegetation data and others, and also to visualize information. Put all the data in a single environment, and this will give you a very good decision-making support in the form of maps, graphs, charts, or 3D models. So for the purpose of land use, GIS allows using data of remote sensing, which allow monitoring of anthropogenic influence in a particular area, estimate scale and rate of degradation of green cover, flora, and fauna. This is one of the most important things. For example, if you just take a land use land cover map before and after, it will not only allow you that the forest or the agriculture that have been cutted, forests have been cutted, but it will give you information that to which class the forest area have specifically transferred. For example, whether the forests have been transferred to agriculture, or the forests have been transferred to building, or the forests have been transferred to other land cover classes. So accordingly, you can make a very good decision of the assessment of the land conversion and land use land cover assessment. Its conversion to other land use land cover classes. You can make a very good plan for decision like that. So assessment of land use can be made in a complex or component-wise indicated the test site depending on the goal. For example, it depends upon your goal. If your goal is agriculture, to monitor the decreasing of agricultural land due to the ever increasing of the human population. If your goal is, for example, to save the forest resources from the anthropogenic activities, or your goal is to save the water resources, so accordingly you can plan depending upon your set goals there. So rule of GIS, GIS make it easy to model spatial distribution of a various type of pollution of stationary and mobile sources in soil, atmospheric, and the hydrological network. So based on the results, on the result of the analysis made by GIS to the optimal solution of land use that provide the minimum impact on environment, make optimal decision of conflict association with land and control of the usage. So one of the major advantage of using GIS is possibility of complex analysis in a concrete extensive aspects. So for a variety of land management objective, analysis method is chosen based on the parameter of the problem and parameter of the use of its result. So you have a variety of methods and you can apply this regarding the parameter of the problem. So if you have some problem and you have to use the specific method, there are a variety of methods which can be used for hydrology, forestry, agriculture, geology, or something like that. And accordingly, you have to use the same parameter for getting the required result. This is also, for example, land use and land cover is a dynamic in nature and provide a comprehensive understanding of the interaction and relationship of anthropogenic activity within the environment. So remote sensing provide, for example, a synaptic view and multi-temporal data for land use and land cover mapping. For example, it gives you a general description of the land use, land cover, and will give you information about the multi-temporal data because the satellite data is not available for a single date. So it's available in a temporal and a different temporal dates. Yeah. So also, for example, land cover include features like water, snow, grassland, forest, and soil. And land use includes agriculture land, built up canal, and other land features. The recent technology like remote sensing and GIS help us by giving a quicker and cost-effective analysis for various applications with accuracy for planning. So also GIS and remote sensing techniques have opened a wide range of avenues for effective land use and land cover mapping. Specifically, the remote sensing data can be combined with field survey data and which provide a unique and hybrid database for optimal mapping of land use and land cover classes, because we are combining the ground survey data with the GIS remote sensing data for generating a model. So this model can further predict a variety of different information that can be used for many applications in the field of space sciences. So spaceborne and aerial images provide information about Earth's resources, agriculture condition, weather pattern, and host of other phenomena that would be impossible to observe from the ground. It's very clear. For example, if you are getting information about Earth resources or agriculture conditions, weather pattern, and a host of other phenomena, that is really impossible to observe from the ground. So this also comes under the importance of GIS remote sensing. Our last is, for example, strategy for sustainable land use planning. As you told that strategy is a kind of long-term planning. So for that, we have to understand that land provides an environment for agriculture production, right? It gives you an environment in the form of soil for agriculture production, but it is also an essential condition for improved environment management, including sourcing function for greenhouse gases in the form of forest, recycling of nutrient, amelioration and filtering of pollutant, and transmission purification of water is a part of hydrological cycle. So, as I told you, that it's complex, but we have to manage this. We have to make a strategy for this, because land not only provide you an environment for agriculture production, but the same land give you environment for carbon sink absorption in the form of forest. The same land area provide help you in the recycling of the nutrients. For example, when this nutrient fall, the soil, there are microorganisms in the soil which decompose. It helps you in the nutrient of the soil. Also, it gives you help in the amelioration and filtering of the pollutants, transmission, purification of the water. As you know that this soil is also a kind of natural filtration of a water. So, and play a very important role in the form of hydrological cycle. Also, the water go and evaporate in the form of transpiration, evaporation from the land. So there are a variety of different things that we are getting from land. Agriculture, forest, water filter, hydrological cycle, amelioration and filtering of pollutants. So it's a complex phenomenon. So for that, we need to do a planning. If you only plan for agriculture production, maybe your second objective will not be fulfilled. So we have to think some area for agriculture, but also we have to think about some area for forest. We have to select, for example, steep slopes for forest. We have to select plain area, for example, for agriculture purposes. So I think it's visible. The screen is visible. Okay. Okay. So it's a little not visible for me because. Okay. Let me check again. This is this one. Okay. So I think no, it's visible. The objective, for example, the objectives of sustainable land management is to harmonize the complementary goal of providing environmental. Have to keep in mind environment, economic. You also have to keep, for example, maximum benefit from the land and social opportunity. So there are three things now involved: environmental, economic, and social opportunity. So environment, you have to think about the soil, air, etc. For economic, you have to think also about to get some income from the source, the form of agriculture crop or forest crop. And also you have to think about the social opportunity, about the people living in the surrounding or nearby or inside for the benefit of the present and future generations. So you have to think. So whenever while maintaining and enhancing the quality of land, soil, water, and air. So whenever we are planning a land use planning, we have to think about its environmental impact, we have to think about its economic impact, and we have to think about its social impact. And we have to, the economic, environment, and social impact will not be only for the present generation, but as well as for the future generation. But at the mean, also you have to think about the soil and water and air resources. So these all you have to keep in mind. So sustainable land management is the use of land to meet changing human needs. That is, for example, agriculture, forestry, conservation, while ensuring long-term socio-economic and ecological functions of the land. This is. So sustainable land management combine, for example, technology, policy, or activities aimed at integrating socio-economic principle with the environmental concern so as to maintain enhanced production. So this is called economy. To maintain enhanced production. The second is reduce the level of production, raise and house soil capacity to buffer against degradation. That is called soil protection coming here. Protect the potential of natural resources, prevent degradation of soil and water quality is also protection. Be economically viable also, and also be socially acceptable and ensure success to benefit from improved land management. So you have to think about an economic sense and you have to think about the protection of soil, protection of air, protection of water, protection of forest. Economically, it will be also viable, but it also be socially acceptable for the people which are living there as well as in the surrounding. So I think that was the end of today's lecture. The theory about land use, land cover, and land use planning, rule of GIS and remote sensing, and also some strategies for making land use planning. So I hope you guys will know some idea about the land use, land cover, land use, land planning, and also the rule of GIS in remote sensing, in land use, land cover classes, etc. So this was the first, for example, our lecture session, but we will have, I think, a short break. After the break, we will have these 3 sessions of the practical. Like, for example, we did unsupervised classification last time, but that was not that much successful. We will do today, inshallah, unsupervised classification. Again, we'll do supervised classification. We will do after that the open source or statistical software for image classification. So I'm much more important that to motivate you guys for the classification of satellites images using the R statistical software. And finally, we will produce today, inshallah, a map, a digitized or classified map, and this will be our goal. So today we have Mumtaz with us. Horace is not available. So we will have, I think it's 1:06. We will have some 20-minute break. Maybe I will pray. And then after, I think after 1:30, we will start our practical session. But in the meanwhile, if you have some questions, you can tell me, or you can just write in the text box. I will try to answer all of your questions. I think this is a good thing. So see you after 20 minutes, or maybe after 1:30. Yeah, if you have any question, you can just tell me. You can just write in the text. Yeah. Okay, so just write in the text if you have questions. See you after 1:30, inshallah. So we will continue with our practical sessions now. So let me share the screen again. We have this yes, arc map. So I think the screen is visible, the arc map screen. So all of you can see. Yes, right? Okay. Okay, fine. Okay, so if you remember our last 2 days exercise, we downloaded one Landsat scene, we pre-processed that scene, and we will do our practice with the same scene. Yeah, again. So I'm adding this scene. I have this scene somewhere in a folder that is study area. Yeah. So this was the scene that was prepared. So I'm going to the property because it's not clearly visible. Let me stretch a bit so that it can be visible. Still, it's not that much. Yes, I'm stretching tool, another one. Not with this, maybe histogram equalizer, no, with the standard deviation. So with standard deviation, it is much clearly visible now. So that was the scene that the last time we processed. as I told you, if you remember that we have two type of classification that time. For example, let me change the screen to that. That was, for example, this one. Yeah. That was the image classification, as I told you, our last exercise, that the classification algorithms are two types. The first one was, for example, was pixel base, and pixel base was, for example, supervised or unsupervised. So in supervised classification, as I told, that the spectral features, some area, known land cover, are extracted. For example, you have to train the software and you have to guide the software, and that sample can be in the form of training area. So based on your training sample, the software will classify the satellites image into different land use land cover classes. But the unsupervised classification, as I told you, that you just have to give the number of land cover classes. So based on the land cover classes, a software automatically classify the satellite's image, and they are doing based on the homogeneity spectral response of the of the satellite's scenes. Okay, so we will repeat this again, because I got some email from some students to repeat them, and then we will go with the our statistical software. So I'm sharing the screen, so I think no, it's also visible. So first, as I told you, that if you open your satellite scene, you have this classification. If you don't have the classification, just right click here and unclick image. But if you just like here, the image classification will be appear. So very simple, as I told you, this is the unsupervised classification, where the classification automatically classify the satellite's image for you. We will do this first, for example, classification, and then ISO cluster unsupervised classification. You have to click on it. So it's open now. We don't need to do anything with this. The satellite scene is already there. The number of classes, for example, you can give, depend on you. For example, you want to classify your satellite's image into 5 classes or 6 classes or 10 classes, whatever. But I recommend to give a little more classes, and then you can merge some classes. For example, if the classified your forest area into 2 or 3 different classes, then sometimes it's very good, because it's very difficult to classify between broadleaves and conifer, but sometimes the classification algorithm is doing this for you. So suggest to give some more classes, and then if you think that both of these classes belong to same class, then you can just merge them, or it's easy. So at the moment I'm giving, for example, 6 classes to it, and I'm saving the output raster that is here, maybe somewhere unsupervised. I will give you a little different name, this one. So save, and then you can go with the okay. So the process will start. Hopefully we have some result now. If you want to see if that your computer is busy, you can go to view processing and go to result. So you can see that some processing is going on here. This is, our result of unsupervised classification. It takes few minutes, but the story started after that, because now you have to decide that what was classified what, and you have to label this accordingly, something like that. For labeling, just right click here and go to open attribute table, and you can add, for example, here add field. And add field, you can just write, for example, name, yeah, and you have to select text, because this will be in the form of text, and then okay. Here you can write the name of each land use land cover. But for identification that what is below, you can go with the same, and you have the original satellite seen in the background. For example, if you can uncheck this one, you have this. So it's mean that the dark blue color is water bodies in this. So just come here and go to start editing, and it means that number five is water. So here I would suggest this is, you can just write, for example, water bodies. So this you did this. Okay. The second thing is that we are going with that. For example, this class, this color looks like, for example, number one looks like more forest land. Yeah, this exactly looks like, for example, forest, because this is a natural pine forest, and they classify number one as a forest. So here you can just write, for example, forest land. Okay. So two of the classes have classified now. Now we are coming with this green color. That what is this? This greenish type. But this is also seemed like a forest, or maybe a little different forest, but it seemed like also a forest land, this green color. Maybe a little, not that much dense, but also forest. So I'm giving also name to this forest land. As I told you that sometimes it's possible that you have two classes for a single land cover. So this is also forest. And after that, we can see the color like blue color. Not sure what was this, but this seems to me a rainland, because you know these are kind of on the top of mountains. But they give same color to rainland as well as to agricultural land, because almost agricultural land is and rainland is a big problem to us, and because both have the same spectral characteristics. So this is up to you then how to improve the classification, but that was unsupervised classification. So unsupervised means that there is a problem between the rainland and agricultural land, because majority rainlands are a kind of herbaceous vegetation, and also agricultural land has the herbaceous vegetation. But sometimes you can do, yeah, there are a lot of techniques available to separate agricultural land from rainland, or you can just take a satellite scene from the time when there was not present agricultural land. So when the agriculture crop has been cut and the land was looking like a barren land, or you can just select, for example, the area which is just on the side of the river. This can be agriculture, but the area of the vegetation which are present on the top of the mountain, this can be, for example, rainland or grassland. So these seem to me, this number four seems to me a kind of rainland, because it was classified in rainlands. Okay, so we have left 3 and 4. 3 and 4. So 3 is this. We have to see this orange type color, and let me check. This looks to me a barren land. Yeah, this seems to me a barren land. Yeah, and this bluish type. So no, this reddish type. This is 3. This seems like a barren land, but it's up to you. You can just change the name or whatever you want. The most accurate way that you do some ground inventory and by physically see some parameter on the ground, and then according to the ground parameter you can classify that thing. So what is, for example, now we have left which class? We have left 2, class 2, no 3. We left 3, but 3 was done just right. No, 6, 3, and okay, and I think I give this rainland to 5. but that was actually 3. That was, I think, Rhineland, and 5 was Barrenland. Was this was Barrenland, but that was again Rhineland. But what is Rhineland? Let me search if it's might be glacier. Yeah, it's selected. Yeah, the okay. So I will give you some here to glacier, but you can just change or play around. It's just changing of the name or something like that. Glacier. So we have this name now. We rename, as I told you, just give the number of classes, and after the classes, you need just a labeling. If you go to the lecture, for example, as it was here, that was the lecture. That in unsupervised, the computer program automatically group the pixel into the image into separate cluster, depend on their spectral feature. Each cluster will then be assigned a land cover type. So the software will automatically classify that scenes. After that, for example, we give the name that this is water, this is conifer, this is agriculture. After classification, which we call it a kind of post classification, we give them the names to it. So as you remember, for example, what will be the color? We will go also with that lecture. If you remember the color, as I told you that what the GIS website is following, that was for example, for agriculture, we have to use, for example, this light brown. For urban built up, to red. Rainland, we have to use this orange, and for forestland, we have to use green, and fodder, dark blue. Wetland, we have to follow this color for the mapping purposes. Yeah. So let's go to the practical parts. So it's, I think, visible. No. Okay. So just go on the property and go to field, and in case of instead of value field, you have to write names. Then apply, you will have the names of it. So for barren land, we will select a different color. Maybe for barren land, we will select some these. For forest land, we will select green color. For glacier, we will select white color. For rainland, we will select like this, and for water body we select dark blue color. So now we have this map, and it looks really sense, because if you see the forests are very good located. Let me check the source, general symbology, display field. Okay. But I would say that the glacier is a kind of, I think we made a little mistake, because the glaciers are the blue color. I think, yeah, the glaciers are blue color, and the barren lands, or maybe barren lands are the water body, something like that. But you can just play around with it. So the forest is very accurately classified. I'm confident on it. But I think the white color, which was glacier, that is not actually glacier. That is actually water bodies. Okay. So I will go with the again with this start editing stuff. Let me check. The glaciers are, I think, water bodies. And water bodies are, I guess, glacier. So let me do it again. Stop editing. So let me change the name again to it. Symbology. Barrenland, forestland, glacier white. Rainland, these, water blue. So okay. No, but we didn't change the name. Okay, barrenland, it's can be these: forest, glacier, rainland, and water body. So you can see, no, it's look correct, because the water are really makes sense, because you know the river which is flowing in the middle of the satellite scene is clearly visible now. This is the river actually, we know, because this is I already work on that study area. And the rainlands are also very accurate. Barren lands are very good, almost done. And also we have little water bodies here is just because there is a glacier on the top of mountain, so it's a kind of floating water which are coming from the snow covered mountains or something like that. So that's the results of unsupervised classification. After that, you have to go with the open attribute table and you have to calculate the area of everything. So we'll give, like, for example, area, and we'll do with the, for example, double integer. Okay. So for area, very simple thing is you have to know what is the spatial resolution of your pixel. So let me check. It's 15 by 15 meter. So just go to open attribute table, right click on the area, go to field calculator, yes, right on the count, multiply by 15, multiply by 15. This will give you area of each land cover in meter square. But if you divide this into 10,000, it will give you area in hectare. Yeah. So let me do this. So now we have area of each land cover classes. Each land cover we have area for each land. For example, forest land we have 24.32 hectare. Okay, Ebrar, you raised the question. Ebrar, okay. I think Ebrar, you can just write in the chat, okay? Because I don't have, I think I cannot allow you, but you can just write in the chat if you have any question, okay? Right, Ebrar? Okay. So this is another area. We have 25,536 and 16,406, 12,194, something like that. So now we have area. You can even calculate how do we know that pixel is 15 by 15? Yeah, it's very simple. This is your classified scene. Just right click on it, go to property, and write on source. In source, it's clearly written that the cell size X and Y. This is 15 by 15. So I hope, Ebrar, your question is clear. You can do even some graph. Also, you can just right click on it and make some graph of different options. You have different option of graph. So you can also make some graph here also. It's possible, you can just play around, okay? So that was the results of the unsupervised classification. We just give the number of classes, 6, and then after that we label the classes, and then we have the results. We have the result. The second, we go with the maximum likelihood. This is actually a supervised classification. And supervised classification, as I told you, if you remember, I guess my previous lecture, that we have to train the software in the form of training signature. We have to take some homogeneous training sample of the land use, land cover. So when you take this training signature in the form of polygons, you can create, for example, a training signature. And it was just, I think, like, for example, if you go here, this is it's available simple trainer. If you click on it, the bar will be open, okay? The training sample manager window will be open. Just go and, for example, you just click here, make a sample, give a name. For example, this is the sample we took from a forest, just give a name these, and finally you have to go with the saving tool that will save the training signature. But we already created this many times, so I think we have this in the folder, also the training signature. So for supervised classification that we already produced, we already created the training signature, we have to go with the maximum likelihood. The satellite scene is there. You just have to give the input training signature, which is saved in the folder where you save that. So that was, I think we created this trend seg in the form of trend seg 3, and just open that. So when you open it, the training signature, you just have to save the output file. For example, supervise, I will give you supervise land use land cover classification to save, and then go for the OK. So this is the result of supervised classification. We have 1, 2, 3, 4, 5, 6, 7 classes. Yes, I think I produced that time 7 classes while preparing the training signature, and these are the results. So, but then you have to go with the level. For example, go to attribute table, and then you have to add field. Here you have to write name. The names will be in the form of text. One field. You have to add another field, for example, for area, and that should be also double, and then okay. So you have to column in the attribute table now, but you have to know that which class is classified what. For example, this red color seems to me forest land for me. That seems to me forest land. Yeah. So I will give you a forest land area. The one is, for example, for me. So you have to go with the start editing. Otherwise, you cannot write it here, data and start editing. And just write, for example, forest land. So that's done. We have it, the forest land. Here, as I told you that in unsupervised classification, we face one problem of the agricultural land, but here we took some sample from agricultural land. So the agricultural land was also classified very good. So number 4 seems to me an agricultural land. This seems to me an agricultural. Okay. Agriculture land. This is agriculture. The third is, for example, the dark blue color. This looks perfectly fine. This is, for example, 7. This is water body. So water body. After that, we have some other classes. For example, this orange color seems to me a forest, but not a dense forest, but let me check. This was classified, I think, in the form of rangeland by the classifier algorithm. So this seems to me 12 rangeland, or you call it grassland. But if you are not agree with this classification, you have to develop your training signature. You have to make more polygon in it. You have to do again and again. So it takes a lot of time for improving the result. So I give rangeland, which I usually give for agriculture land. So this was selected. That's why. Okay. Later on, we have number 9 left. Number 9. This is kind of bluish color, or also we have number 7 left. Number 7 looks me, no, this already done. Number 9 is if you come here, this seems to me, for example, let me check glacier. Yeah, number 9 is seems to me glacier. Yeah, this is number 9, or maybe snow cover glacier. Right, this is right. And we have this small, this is number 14, patches. Not sure what is this. This one. This seems to me also a glacier, but kind of moving water from the glacier. Yeah. So I think I will give this also for me. I will give you water, because this is a kind of floating water from the glacier. For me, it looks like this, but we are just doing a training, so I'm not that much serious in the classification. But when you are doing some practical work for practical application, you have to be much more conscious on it. Okay, so I'm also giving a water bodies. So then we have 14, and let me check what is 14. 14 is, no, I think we just, sorry for the small interruption of internet. So the 15 or maybe 13, that was water bodies. That was, I think, this is this we have to find out. This is, for example, 13 little different color 13. You have to find out that what is this actually. No, this is I think not that much. Your internet is unstable. Huh? Yeah, but I'm visible now. Okay, so this is 13 actually. 13 is it's very less pixel, I guess, just some mountain or something like that. But let me check this mountain. These are also a kind of, for me, it looks like orange lands. Yeah. Okay, so that's actually the labeling process. But you have to be very much familiar with your study area. Okay, or the most accurate way is that you have to do ground inventory. Just take, for example, GPS with you, go into the field, stand in the forest, make a polygon homogeneous. Take a GPS with you, go to the field, make a polygon. Training session. Sorry for the internet disruption. So I'm facing a little problem with the internet, but I hope it will be resolved. So okay. So that's what we did. For example, for agriculture, forest, glacier will go white. Rainland will go little yellowish, or rainland again yellowish. For water body, unstable. So I have a little problem with the internet. So you should be on. Hopefully you're working. So this is the results of the supervised classification. You see the forest here, the rainland, grassland is the yellowish, glacier, and the other thing is also there, and that's the reason. And this is the results of, for example, unsupervised. So that's really different. Okay, sorry once again for the internet. I don't know what's happened with the internet. Okay. Okay, so now we have also result for supervised classification, but no, I'm facing a problem with internet. So hopefully I'm getting messages from internet that internet is unstable. So hopefully it will work. Then we go with the new software that is, as I told you, the R statistical software. Okay, right? So let me open the R Studio. That is for you. Okay, let me also introduce you a little bit about this software. Also change the things, maybe to it's open or not. It's open now. Okay. Later. So I hope the R Studio is visible for all of you know. They actually are. So R is, as I told you, it's a free open source software for statistical analysis. And R Studio is, for example, also free, but it's provide, for example, it's an integrated development environment for running the R. So these both of the softwares are free. You can download, but first you have to download the R, and after that you have to download the R Studio, and both will be in a single environment, and then you can work easily with it with the R Studio. But it's a revolution. It's a great software. You can develop a variety of statistics. You can do a variety of analysis with the R. And we, as a remote sensing people, we are using the R Studio for our own advantage. Yeah, there are thousands of packages available of this R, which can use which are specializedly developed for geology, forestry, agriculture, for a lot. For example, with remote sensing, we are using this. This is actually a statistical software, but for image analysis, it's just because that we will be using some packages, some software with it. So that's a great software. So I really recommend for researcher. I hope many of you know, but without R, nowadays with Python and R, working with statistics or remote sensing, for me, it's not making sense. So this is a great software for working. Yeah. So that's actually an R. The very first task of you will be to link the folder with where your data is saved. For example, where your specific data is saved. So very simple. If you go to here, debug or tools, just tool, or maybe session. In session, if you go to click on session here, just go to set working directory. So set working directory, you have to go with the choose directory. So you have to link the folder. For example, my folder is in I7C, and then if you enter training, so that is my folder. So it will be linked. So it's come here. When you are applying here, it will be appear here. So the first was like setting, linking of your desired folder. Okay, and just copy these. So the codes are automatically be saved, because at the end you don't need to work. Just select and your code. So next time we don't need to work, and you just select and run. It will be run automatically. Okay. So your screen is stuck up at the beginning for us. So now it's visible. Our studio is visible. But there is no slide. It's just a studio. A studio nakari. Okay. Okay. I don't know what it is. Oh, net safe. Net. Huh? Okay. So let me share again that why it's not working, but maybe because of the internet is slow. So Suleiman, the RStudio screen is visible for you, or due to internet connection, it's very unstable. Suleimani, can you see the screen now? Okay, so okay. So as I told you, the first job is to go to session, set working directory, choose working directory, and you can just select the folder where you want to link the folder with the RStudio. So I did this, it's automatically appear here, and I save the code here. Okay, linkage is a linking of your desired folder. Okay. The second is, for example, as I told you, you have to install your packages with it. So the most simple way to install your package, just click on the package, okay, and click on install, and write the name of the package here. Okay, so just write the name and then go for install. Then you have to wait. It will automatically download the package, and then it will be installed on your computer. So once it's installed, you don't need to repeat it again. You just have to run the package. So I already installed. I don't need to do it again. Okay. So for example, what package I need for this? The most important package I need for this is, for example, Carrot package. It's one of the greatest package, and a lot of machine learning algorithm analysis can be done with the Carrot package. The second, for example, is I would say a raster package, because the raster is the package which can even handle the satellites data, the raster data that can be used. It's the raster package which can handle the raster data. The third package, as I would suggest, it's RGDAL. This is actually used for handling the, for example, the vector data with each one. And also we need to have some other package, like, for example, maybe current lab, and also some other packages, for example. Yes. Cannot hear? It's not visible? It's not visible. Can you stop sharing and again the share? Okay. Let me share again the screen. Okay, so this, and I think I have two screens here of RStudio. Both can be visible, but this let me screen one. It's right. It's visible. Yeah, it's right. Okay, it's right. So they can see. So you have to download all the required packages for instance. And you know, as I told you, there are thousands of packages available for different application. But we are actually using these packages only just for remote sensing, image analysis, machine learning algorithm. So E101 or kernel lab actually can be used for support vector machine classification. Yeah. Okay, so visible but didn't see the previous steps. Okay, yes. So these are actually codes. You just copy and install. So just click on it, select this, and then run. So if you already install these packages on your computer, you don't need to install it again. So you just have to select, for example, all of them and then run. Okay. So it's mean that do not show me any problem here. It means that all are working fine. But if some package is not installed or there is problem, you will see a red color behind here while processing. For example, if you just write library raster, you will and run. So it's not a problem. I mean, it's installed. But if there once again, sorry for the interruption because I don't know, I'm facing serious issue with the internet connection, but we will continue. Okay, so there is an uninterrupted problem in the internet. Okay, so this is the packages that you need to install at least, or maybe later on I will share this small group of for example, codes with Horace, and Horace will share with all of you, and then you can do practice on it. So hopefully it will be better for you. Yeah. Okay. So after that, for example, we need to open the raster data. For example, you have to open the data which is saved, but be sure that the data is in the same folder which you link with the RStudio. Okay, so for opening a raster data, you can give any name. For example, I will say raster is equal to raster data, and also the name of the data. which is saved in your folder. So in my case, the data is, the name of the data is, for example, let me check, study area. So this is a kind of the name of the raster data which is present in your folder. So you just have to write raster, because this is actually, you have to tell to the software that this is actually raster data. Or maybe you have to, I also saved some code, but you have to write not, you have to write raster data in case if there is a single band. But you know that our data is in the form of multiple band, so you just have to write stack to stack all the bands here, and then you just write double comma. Inside the comma, you have write the name of your study area and then the top. And if you select it and then run, your data will be appear hopefully in no, your data is in the R software. So just if you want to plot, for just checking whether it's available or not, you will write plot. So if hopefully it's gonna be plot. So why is not plotting? Okay, plots here. So these are here. You can see your data is all the band. Like this is, for example, band 1, band 2, band 3, band 4. It means that all of your data is here in the GIS environment. The second thing is that is the, for example, training signature. Here you have to do, you have to use a little, for example, you have to use some org map for that, for preparing a training signature. For instance, or you have to make a points instead of polygon here. You just have to create a group of points in the form of shame file for each land use land cover classes, which I already prepared in ArcMap. And these are actually vector data shape file, but these are in the form of points. So you will see here. But if you want to open the, for example, the vector data, so you just write, for example, open the vector data just for, you have to write, for example, VEC is equal to read READ OGR, and then double comma. You have to make this code, and then full stop month. And then you have to again comma, and then you have to write the name of that polygon, the training polygon, which are present, which you already create. So I created this training polygon. I think it's kind of. Let me check what was the name of. That was in I think Transec R. I created yesterday. That was for that was the name was Transec R. So if you select, and then you can go with the run. So no, this is also we have also the training points. We call it training points actually, not training polygon. If you plot this, hopefully it will be visible on my right side window. So here the training polygons are available. If you want to see that what is inside of the training polygon, you just write head VAC, a vector name. So we have land cover in it, grid code, and print it. So we have land cover classes here only in this training polygon. After that, for example, after that, we have to extract the value, the DN value from the satellite, from the 4 bands of the satellite thing. We give a name, for example, get the DN values from the raster data using training points. This will be our next one. So for example, we give here, for example, train sec is equal to extract raster data, because that was the data of the raster, and then you can just write vector data. This was the data for polygon. If you click on it, it will start extraction of the digital number. So I think it's extracted. It was hopefully it was very fast. So it's also done. And then we have to write, for example, get the correspondence land cover classes from the attribute data of vector. So this is, as I told you, that if you see the head of the vector, that is VC. So you can see it's in the form of land cover. Okay, so to get this, we have to give a name. For example, train class is equal to VC dollar give assigned to the sub column. Okay, land cover. So this is also done. We separated that here. If you want to check, for example, train class, this is only the number which we give, like 33 for forest, 66 for another, or something like that. So then after that, we want to combine both of these data sets. For example, it's just for if we have some data, no data values. Yeah, no data values. And finally, we have to combine the train sig and train signature. Okay, it's only because if we have some undata values, because which finally creates a problem in the classification. And after that, for example, we give another option, like, for example, data is equal to complete cases data.df. It's only because to remove all the data where there are no values and only show those data which have, for example, values. So this is one step more in the classification. So after that, for example, we have to separate again the training data. For example, let me write separating train sig and train class again. So train data is equal to this given data.df because it's usually, I think, how many column we have. I think it's from 1 to 5. Let me check. We have, for example, heads data.df. We have 1, 2, 3, 4 column we have. So this will separate the data 1 to 4, and the 5 number class we will separate also into another name, train class. Use this name, and then data.df this that 5. It will separate the 5. Sorry, we have to use this one, that is 5, and we have to use this bracket 1 to 4, 1-4. So now our data is separated. The train class and training data both are separate. For example, if you want to check on the we made a little, because I wrote 7. So if you want to check train class, so these are only the land cover labeling data, and then train data. If you check this, train data is not found. Why? Oh, I made a mistake. TRAIN. So you have to be very much care about the spelling mistake, because then it will double N. So I write double N here. So this, now we have also the four values, values in 4 column. This is from band 1, from band 2, band 3, band 4, and we have one trend class that is actually the land cover class. After that, we have to make a model. Like for example, for modeling, we have to do, for example, some creating training models. So you have to go for this. This is the thing. It's a kind of boat strapping, fit control, train control, boat strap, and you have to go with the number 10. So we will reduce up to 1 because it will take a large number of time at the currently just for the practical session, but you can increase. If you increase, the accuracy will be more. If you decrease, something like that. Boat setting is something like resampling of the original data, something like that. Yeah, to getting more accurate results. To create many simulated samples, something like that. So that's we train, and after that we I already wrote some codes for you. For example, I give this name that SVM fit support vector machine train data as a factor train class. Method, you have to select SVM radial to tune length. I keep it to control fit control method kappa coefficient imparted. So these are some of the codes which can be right for the modeling of the for generating the model. But I think it will take time. Yeah, it will take time because this model actually will take time. Specifically, if you are working with deep learning algorithm or neural network, something random forest, or with a large number voting, it will take really a lot of time. So it's done. After that, our model is fit. We are ready. Our model is ready, for example. And after our modeling, we have to give a name, for example, out image is equal to, for example, we write SVM classification. That we are giving the name. For example, I will give you, for example, 5 because I'll get some classification. SVM classification test. Okay. So this is just a name of the output raster that I give it to it. So it will be also some code. And then SVM, what is this? Opportunity not found. What does this mean? What? Okay, I think I will copy the codes. So I don't want to be these are the code, but I will give, for example, 5 because I already have this that image. So this is done. So finally, based on your train model with the training and testing data, it will predict your entire raster. It will classify your entire raster. If you can have a look to this code, SVM predictions mean that based on the SVM model, predict raster using the SVM fit model. File name is the output image that we give, number of rows, true progress text formats. We need the data in UTF format, data INU overwrite is true if they already exist. This will produce our final classified raster. So it started, it will be in the form of percentage. If it's when it reaches to 100%, means that we are done with it. At the meanwhile, if you have any question, you can ask, because I think it will take too little time. Yeah, you can ask, or you can just talk with me. But that is only a one classification algorithm. So R is a very great software, statistical software. We're doing a lot of analysis nowadays with R. For example, we are processing LiDAR data, 3D data, remote sensing with R statistical software. We have separate, for example, packages for LiDAR data. For image classification, we have different data. So it's really a great, and it gives us a great result. And the most important thing is that we have independency of changing the parameter, the tuning parameter, the modeling techniques. So we have this independency, specifically using the statistical software. You can use your own model. You can develop your own model. You can generate your own codes. For example, right now we just generated our own code, so we don't need a licensed software. So we develop the code, we apply the codes, and hopefully we will have the output right just now. So it take time, but at the meanwhile we it will be 100%. It's 100%. It reach. It's mean that we are done. But I already tried with this, so I have the results. So, and we will open in ArcMap. Okay, so let me open again the ArcMap, which we have the results. And let me share also again the screen one. So that was the results that we explained. That, for example, as I told you, that was our satellite scene, which was produced from pre-processing step. After applying unsupervised classification, we have these results. After applying supervised classification, we have now these results. And now we will go with the R statistical software that we apply with the support vector machine. So I already did this supervised SVM, this one. That was, I got the result yesterday from that. So this is also, you can see, this looks me forest. That was some result. Forest, and but we have to go and deeper. We have to see that what is actually which, what is actually is. So let me check. This is, for example, the green color. The number 3 looks me water. This seems to me water. Yeah. And this seems to me, let me, blue color seems to me a forest also, but maybe the oak forest, not the pine forest, or maybe the rainland. This seems to be more like rainland. So see, no, this is the results. As I told you, this is our support vector machine, but you have to improve more and more your training signature, and you have to apply again and again this training signature, and finally you will have the result. But the most advantage, when you have this code once, all of your codes in your hand, so then your job is done. Okay, just improve the training signature. So it's going on. So we have no codes for classification. Just select all the codes at once and apply run. It will automatically take the satellite data from that folder. It will automatically take, it will automatically install all the desired packages for you, and it will automatically take the training sample data from the folder which you already saved. And it will automatically tune its own model and training by testing data, training data, and finally you will have the output. So once we finish, we're done with the code, you can just save this code and just select and run, and automatically everything will be done. And finally you will have your output in the form of classified map. So this is what I'd suggest, that it's really a great software. So you just make some changes. For example, next time you want that I want to change the tuning parameter from number to 1 to number 2. Just change it, or you want to change the tune length like to 3 or 4, check the accuracy, do it. So this is the beauty of this software. Like also we have the same environment like this in Python. So just select and run it, and finally you have the products, the classified products. So you see 50% image is almost processed, so it's still continue. So that was a little bit about these three statistical software, like unsupervised, supervised classification, and finally non-parametric support vector machines. That was the image classification. So our final goal is, for example, to establish, for example, a map, final map, which is very easy. If you have this map, for example, for instance, let me check why this is coming the background value. Okay, and what's about this background? Display, data source, general symbology, RGB composite. It will go with the RGB composite. Okay, so if you have these, just go with the here. It's a layout view. Just click on it. Your data will be like, for example, like this. You have then a map view. Your final so make it a little bigger, because normally you have to select the size, because the map looks like that. It is more square as compared to rectangular block. So go to file and then just go with the print touch setup and go for landscape option. If you think it's more suitable, you will have more setting than here. So more setting parameters. Okay, and you can just increase the size more. Yeah, maybe a little less. So finally, you have to play around, and you can make whatever, which kind of mapping you can do. But the most important, you need a title for it. For example, just click here. For example, like land use, land cover, map of deal twist, and for example, map title. If it's very smaller, make a bigger. Then use land cover. For example, I give this name. So make a little bigger, attach here 28, and then okay, apply, and this, you will have the title of your map. This is actually important. Or maybe you can go, the second important is the north arrow is important, because every map will have a north arrow. Without north arrow, nobody will appreciate your map. So this is, for example, north arrow. After that, you can bring the legend, for example. Okay, legends. So legends, you can also play around or make a very better with legends. So we have the legend for that. No, so I want to edit the legends because I don't like the supervised classification on the top. So ungroup, and then you can just delete some of the things which you don't want. So bring it here, legends. Okay. So I will also delete this one because this looks a little ugly. Yeah. So just select all of them and make again group, and you will have the regions also here. So this is also important because the people will not understand your map, that what is this blue color, what is this green color, or what is this yellow color, means something like that. Also, I have two legends for Rhineland. You can even, because of writing different in the attribute table. But if you correctly spell right, then it will be a single thing. So I deleted that. So then select again, and your regions will be here also. But depends upon your time and we have no legends. The other important thing we need, for example, scale bar with it, because this is also important. And you have to go here, and this is scale, and it's up to you what level of scale if you need. So you have to select, for example, in kilometer or maybe below center. You have to play with it, okay? Accordingly, you will have different scale, different kind of scale with the number of these, and your map can be measurable because scale is important. Without scale, title is important. For example, your north arrow is important, scale is important. It's not looking that good, so I want to go with the subdivision, but still you can make it a little big or something like that, and you can adjust somewhere another place, like that. Yeah. The other things, finally, if you go to the map option data view, so general mode. This is not. Let me check. What is go to properties, data frame, or general. Or, I don't know why it's getting problems. So you can even also add some grid to it. But before, you have to know that which kind of grid you want. So this is also one of the properties. You have to go grids, new grids. Next, label only, or if you don't want the line, you can just go with the label only. And your map will also have some grids, but you know it's looking a lot of grids in the background, so you have to go with the labeling option, with the interval option. So you have many options here, left, right. You have many options of the grids, and you can, for example, property and play around. You will have also the solution for the interval, maybe little 90. Let me check if it's 90. So you can even decrease the grids, because also you can little increase the size, because it's not clearly visible for for your map. Almost many things should be clearly visible for reading, for output. So it depends on you what level of map you want, or which kind of map you want, and what level of detail you want. But you can also even still, the grids are very like large number. So the properties, interval. So I would suggest go with again 90 with more degree like this. So maybe we have a little more less grid. Okay, so these are almost some of the requirements which you need for publishing your final map. If you have all these parameters like scale, title, legend, and north and east, just go to file and export your map. Okay, so you have to go to export your map. So let me, I'm saving in the same folder, or maybe just on a desktop, and you land cover map. Okay, so you have to keep your resolution size DPI at least more than 300. This is important. Okay, you also you have to keep this. So I think we have now our map. This is C 100% result tube with the R, and also let me see the map. This is our final map. I think it's not visible for you because I have to scare the scene. Place. This is the map that we got it now. So the map is visible. We have, for example, agricultural land, forest land, glacier, rainland, water bodies, and also these things. But also along with the map, you can even produce some statistics of the Excel, some bars, some charts, or you can just do this if you don't want to use. Let me check. Let me share the screen again with this one. Okay, so I think if you don't want to use, for example, want to make your chart here, you can even bring this data, the attribute data, for example, just right here, right click, and then export data. Export data, save it somewhere in the folder in the form of DBase format. Then this data can be easily opened in Excel, and then you can make graphs or do some analysis or difference or something like that. And also some graph can be easily made here. For example, here graphs. If you unsupervised, if you value fill, I would say area. So you see we have no an X field. For example, we say names. So we have names, or in X level, what's it's here, okay? So you will make different kind of graph from it. So now we have barren land, glacier, and these. If you want to go to next, you can go right footer, graph legend, or something like that. You will have finally your graphs, graphical representation of your forest land is something like this, and then for forest land 2 times, and then something you can make this kind of graph along with the legend. This is also possible, but you have to play around. So I hope you have got some idea about the image classification, image analysis. So this is actually what we are doing with remote sensing. Like, for example, the acquisition of information about any area without having any physical touch with that area. So I'm sitting in office. I just took one satellite scene of one of the forests in Pakistan. I classified that forest or agriculture land or barren land without physically that area. And finally, I have the information in the form of maps, in the form of graphs, in the form of digits, in the form of things. This is actually the entire process of remote sensing, to acquiring the data from satellites and then process, analyze, and then but with the help of experts. So you should to be experts, and then finally you will get some results. So this is all about actually the remote sensing and processing image analysis. But at the meanwhile, if you have any question, I'm here for 5-10 minutes, or you can just write to me. Or if you have any question, I will also share my email. Okay, this is Sir, being researcher of remote sensing in GIS for environment climate, though expert of GIS, however, having no background in programming language at all, which may be preferable and relatively the one user-friendly to start with or else Python. Yeah, this is actually a question. Assalamu alaikum from Tariq Sardar, Dr. Tariq Sardar. Really, Dr. Tariq, if you want to see your future in GIS and remote sensing, so I would really suggest to start with the R and Python, because this will be a very good start. As far as the other softwares are available, like ArcMap or FDAS Invasion, NV, these are readily available software. So you cannot do that much innovation in that software. But in R or Python, which almost have the same coding, so it's not that much different codes, but a little environment is different. So it's really good that you can start with the R for beginner, because there is the beginner guide. It will be available in the internet. You can just start with the R for beginner course, and hopefully you will be good in the near future. Yeah. If you have any question, you are most welcome to ask. Yeah. So today my third day, and tomorrow I will talk about forest. It will be the entire discussion will be about forest, how to use remote sensing for different application in the field of forest sciences. If you know anyone, I mean the forestry student, you can even share the YouTube link with them. So at least they will also be helpful. We will talk about different kind of remote sensing application in the field of forest sciences. So yeah. You are most welcome, Tariq. Yeah, yeah. So any questions? So I would really suggest to work with it. At least create some maps of land use, land cover of your respected area from where you belong. So what is the difference between making a land use, land cover map by just adding simple base map and start digitizing, making polygon and the way you start us today? Yes, so you can even open your base map and you just make a polygon, but it will take a lot of time, specifically for the big area, forest area. You can make a single polygon, but inside the forest area, there are thousands of barren patches. So how you will make polygon on that? So there's building, for instance, you will make a habitation by using just make a single polygon, but there are hundreds or thousands of patches of grassland inside of the building. So it will be a lot of time consuming. If you go, the simple polygon will make sense for a small roads, etc., but not for a mix land use, land cover class, specifically for forest, agriculture. Inside of the agriculture land, there are a lot of paths which are barren of walking tracks. So how it will be possible with the polygon? But although I would suggest to go for the object-based detection, object-based in recognition software, it automatically develop polygons on every object. So you don't need to do it, for example, practical with the hand. It will take a lot of time. Yeah, yeah. So if you are making only polygon on a base map, it's a kind of just digitization, not classification. Yeah. So classification is a different thing. You are just making polygon and shape file, something like that. Yeah. Okay, so I will write my email. So my email. Right. Some thread of email. Okay, Mumtaz, are you there? Haris is not present today. Anyone from Comstech, Islamabad, from the IT of Islamabad, Comstech Islamabad? Okay, so that's, I think, enough from my side from today. But if you have any question, please just write to me and hopefully see you tomorrow. We will be in touch tomorrow. If you have any question, you can even ask tomorrow. Yeah, so I hope not many of you have question today. So that's enough from my side. Yeah, you're welcome. Yeah.